Detectives, detectives, there's been a horrific crime.
Spin move. When you go behind the police barrier, just, well, you'll see. That's the crime! Sorry.
Who would do something so barbaric?
What I do know is that with the power that Git gives us, we will bring this criminal to justice. All right, Refi, so to start with, we need to go back in time. We need to go back to when the crime was committed. Well, Refi, you've been doing this job long enough, you know we have, and it's called Git. Because Git can store changes over time, and you can go back to any moment in time. And there's a bunch of different time traveling I want to tell you about, 3 in particular. There's the just visiting variety. You pop back in time, have a little look, and then return to the present. There's the do and undo, which is actually moving forward in time, but taking something from the past and flipping it. And then there's my favorite, danger mode, going back in time, but a little bit more permanently. We're going to look at each of these variations of time traveling with an explanation and a diagram, because diagrams are better.
The city, a vast repository of stories, each one branching out like the threads of complex code. They say every commit tells a story. So, what's my story? Failed developer turned cop? Couldn't write code, so decided to pick holes in others? Maybe it's me. Maybe I'm the issue in this reposa city. All I know is I'm the city's most trusted InvestiGITor. Lately, something's changed. Whispers say there's a new kingpin in town, pulling all the strings from the shadows. Goes by KB. Whoever it is, they are the kind of criminal that doesn't leave fingerprints on the keyboard, just a trail of cryptic commit messages and coerced histories. Anyway, this city is my home directory, and I'm here to clean up the code smells and corrupt blobs, no matter how many conflicts I have to resolve.
Welcome, ladies and gentlemen, to Crime Scene InvestiGITor, the case of the naughty commit. Welcome, cadets, to your very first day of Detective Academy. Now, you've all just graduated from basic police school, and you think you're hotshots. But you're in my house now. You're in the real world. Who am I? I am Chief Inspector Detective Cadell, and I am a principal platform engineer for Android at a company called Babel. And when I'm not Androiding or platforming, I love the terminal, Bash, and got really obsessed with Git. Now, as it's your first day of Detective Academy, we have a jam-packed schedule. To begin with, we're all going to get on the same page with the basic internals of Git. Then, excitingly, we have a mock fake crime scene for you that we've set up, where you'll investigate a crime and bring a fake perpetrator to justice. Everything I cover here today will be notoriously documented in this Linktree link here. The QR code takes you to the same place. And of course, you are more than welcome to take photographs of my handsome self or anything up there. But don't worry if you miss something, because the slides themselves are available. Now, I need to do something important. I need to introduce you to my partner of many, many years, the one and only Detective Refi.
Hey, nice to meet you, folks.
Now, Refi is a fantastic sidekick. He is like the Robin to my Batman.
Despite what this guy says, I'm the real brains of this duo. Somebody's gotta keep Detective Cadell from walking into open manholes.
Refi, we talked about this, buddy. We weren't gonna say that in front of the cadets. Anyway, folks, Detective Refi is a fantastic partner and can be trusted entirely. Now, moving on, the work of an InvestiGITor is not about assigning blame to an individual. No, it's about having the power and the skills necessary in Git that when a problem in your repository does arise, you know how to quickly and properly solve it for your team. Let's dive in. Spin move. Thank you. So Git, of course, is a version control system, meaning that it tracks changes to your repository over time. As your files and folders change, Git keeps track of that. It stores these theoretical moments of change in these things called commits, and they are diagrammed like these circles in this graph here. That's boring. Each commit has its own unique identifier, its own unique ID, which is actually a SHA-1 hash generated from the contents of the commit itself. Cool. So every commit has an ID. Every commit also has a reference to its parent, or the commit that came before it. So in this example, C knows about its parent, B, but B doesn't know about its parent, its child, excuse me, that it left behind when it went out to buy cigarettes and milk that one day. Yeah. And this creates something called a DAG, or a directed acyclical graph. Ooh. It's basically just a fancy way of saying you can pick any moment in time and trace your way back through to the start of history. So every commit has an ID, every commit has a parent, and merge commits, hopefully somewhat obviously, have a reference to two parents. Boring stuff. So we've talked about commits. This is one of 3 types of objects that exist in Git that help Git recreate the folder structure at every moment in time. The other 2 types are trees and blobs, and these are all really easy to understand. A commit is the top, the meta, the container of change, the snapshot in time of the save. Within the commit object, there is a single tree object. And this tree object can be thought about as like a printout of a directory. I've LS'd a folder, what's in it? So this tree is the root of your directory. And then tree objects within them contain other trees, aka subdirectories, and blobs, our final object types, which you can think about as the contents of files. So with this weird 3-object folder nonsense, Git is able to recreate your repository at any moment in time. But where are they stored, Detective Cadell? Great question. Are they like physical things, these objects? They are. They are files that are saved in the .git folder on each of your machines, because Git is a distributed version control system. More about that later. So these objects are files that you can touch and feel. Please don't touch and feel the files. That's weird. Can we interrogate these files then? Can we maybe cat out the contents of one of them? Well, mostly no, because it's compressed gobbledygook nonsense. However, we as InvestiGITors, professionals, need some tools to interrogate these objects. And Git itself gives us the answer with the Git command line. Just out of curiosity, everyone with green headphones, if you use Git from the terminal or from the command line, raise your hands. Let me see those hands up high. If you use Git from the terminal, good. Those of you who raised your hands, great job. Those of you who didn't, stay behind after class for a conversation. Good. Anyway, the reason that we're talking about Git from the command line is because, 1, that is how it was intended to be used, purist, and 2, because it's kind of, quotes, the hard mode, so that you learn deeply the concepts behind the command, so that when you go back to your disgusting GUIs, your towers, your source trees, you understand what's happening when you click that button. Now, does anybody know how many Git commands there are in existence now? Just yell out numbers if you know. Have a guess. How many Git commands exist? Somebody held up 4? Bit more than that. Don't know if that's what you said anymore. So somebody in the back said 149? Wow. Goodness. Good job to you. Well done. Don't look back there. He's very clever. There's 149 Git commands as of making this presentation. They can be split into 2 categories. Porcelain commands, which you can think of as the nice, friendly, user-facing commands that we use every day to interact with Git, like branch, commit, etc. And then there's the plumbing commands. These are the scary back-end commands that Git itself uses to do its gittiness, but also really useful if ever you write scripts for Git. Now, we know we've got these objects, these files, these weird things, and we know we've got some commands to interrogate them. Let's learn some of those commands. To start with, listing these objects. We could use the revlist plumbing command with these flags to list all of the objects in our repository. Boring. Fine. Detective Cadell, you've put the readme blob there twice, silly Billy. I can spot mistakes. No. To you, I say no. I did that on purpose, to again prove to you that Git stores changes over time. So the bottom readme blob might be how the file started, and the other readme blob is how the file progressed in a different version of it. Cool. Another command that's really useful is the cat file command. Remember, we can't cat out the file because it's compressed, but we can use git cat file, which does the same thing for us. There's two modes of operation. -t, I'll just skip right over that. It basically tells us the type of object we give it. And then there's the far superior -p for pretty print, or cat out the contents of that object for us. If we were to give git cat file -p a commit hash, it would print out this. Somewhat familiar. It's a commit message. It's an author. It's a parent. Remember I said that every commit has a reference to its parent commit? That's the proof. And the all-important tree object that it points to, the root of a repository. Well, let's take that hash, that tree hash, and put it into the exact same command. And we get this output. It's as though we've run ls on a directory. It's files and folders, or blobs and trees. So let's take one of the blob files and stick it into the same command, and finally you get plain text, your code, right back out at you. Delicious. Makes sense. Now, if you want to learn more about this, I haven't the time to dive into this, but a very handsome cave explorer about 2 years ago took a group of enthusiastic cavers into the .git folder cave system thing. They recorded their findings, and you can find that on the Droidcon content website or on YouTube.
Detectives, detectives, there's been a horrific crime.
Spin move. Yeah. You can start joining me with the spin moves if you like later. Anyway. Hey, cadets, I didn't see you there. So we're at a crime scene. I know I promised you a fake mock crime scene, but I guess there's nothing better than a real gory crime scene on your first day of Detective Academy. Anyway, when you go behind the police barrier, just, well, you'll see. Good luck. It's broken unit tests! That's the crime! Sorry.
Who would do something so barbaric?
Oh, Refi, I have no idea what kind of monster could do this, what kind of criminal. But what I do know is that with the power that Git gives us, we will bring this criminal to justice. Thank you. All right, Refi, so to start with, we need to go back in time. We need to go back to when the crime was committed so that we can see who did it and how they did it, right?
Hey, dreamer, come back to reality. It's not like we've got access to a time machine.
Well, Refi, you've been doing this job long enough. You know we have. And it's called Git. Because Git can store changes over time, and you can go back to any moment in time. And there's a bunch of different time traveling I want to tell you about, 3 in particular. There's the just visiting variety. You pop back in time, have a little look, and then return to the present. There's the do and undo, which is actually moving forward in time, but taking something from the past and flipping it. And then there's my favorite, danger mode, going back in time, but a little bit more permanently. We're going to look at each of these variations of time traveling with an explanation and a diagram, because diagrams are better. So the just visiting variety uses the git checkout command. Usually we pass that a branch to switch between branches, but you can actually pass checkout any git ref. That's a nickname for a commit or any moment in time. So it can take a branch, it can take a specific commit hash, it could take a relative reference like head where we are now or head -1, etc. Here's the diagrams I promised. Hopefully it's very easy to understand. It's a very simple commit history, A to E. We've got head where we are now, and if we were at the tip of a branch, you'll see the branch name. So let's use the just visiting variety, checkout. We're going to jump back to C. When we hit enter, we jump back to C. We're now seeing the world through how it was when C was a thing. Ooh, it's different and older. But notice something else. Our head has changed, but we're not in a branch anymore. We're in something called a detached head state, which is a really terrifying way of basically saying we're not at the tip of a branch anymore. Nice. When we're done having a look at C, we just git check out our branch and we return to the present. Do and undo is the other one. Using the git revert command. As I said, it moves forward in time, taking again a git ref and saying whatever happened there, flip it, invert it, revert it, right? Again, diagrams are better. This is our current state. We're going to use the git revert command with commit E. We're actually going to move forward in time. My head updates, my branch updates. The tip of the branch is now F. And what is F? I didn't type any changes. Well, F is just the mirror opposite of E. Whatever's E's diffs were, for example, minus startup, add cleanup, then F's are the opposite. Add startup minus cleanup. Cool. Nice. And then there's danger mode using the git reset command. Moves you back in time like checkout, but updates your refs. It's important. Again, it takes a ref any moment in time, and it takes a mode of operation. Soft, mixed, and hard. We'll look at those, what they do, in a second. So, diagrams again. I much prefer diagrams. Visual learner. We're going to do git reset soft mode C. So, our head will move, our branch will update. Git now believes that the tip of our branch is C. Interesting. The changes of D and E are like grayed out, but where are those changes? Well, because we said soft mode, those changes are taken and lovingly placed into the staging area. AKA, we've typed the changes, we've saved them, and we've used something like git add to say, hey, Git, these exist. Okay. Mixed is the default and is very similar. We jump to see our branch and head updates, but the changes from D and E are taken and placed into the working directory, as though we've typed the changes, saved them, but have yet to tell Git about them. And you've probably guessed the last one, hard, which is the exact same thing, but the changes of D and E are lovingly taken and drop-kicked out of existence. Sort of, not really. And that's why people say that this is a very dangerous command to use, but it's not when you understand the crux of this entire topic, which is unreachable commits. Now, in the current state of things there, D and E looked like they were gone, but they're not. They're actually still on our machine, still available. They're just not accessible via the usual branch or tagging system, hence they are unreachable. But as I said, they're still there for now, asterisks, okay? Which means we can get them back. If we look at this visualization, it's a better representation of what we got. D and E are sort of no longer attached to a branch. All we need to do is git checkout and the hash that we want to get back, E in this case, right? Again, we're in a detached head state, but we can fix that by creating a new branch and all of our problems are solved, right? But Detective Cadell, in your example, it was very easy. You had single letter hashes, A to E. What happens when we've got our real hashes that are 40 characters long? How do we figure out E? Well, I'm glad you asked. Thank you for that. I want to introduce you to one of the greatest commands called Git Reflog. Oh, delicious. If ever you screw up in Git, pause, breathe, get a coffee, and then type git reflog and enter, and then just relax for a second. Git, as you're moving around, changing your references, your head, your branch tips, etc., Git's keeping track of that locally on your machine in a log. And reflog prints that log back out to you, showing you most recent first, all of the ref updates that happened. And our last one, it's just cut off a screen here, but is a reset command that we just did, and it shows us the commit we went from to the commit we went to. So if you want to get E back, you look at the commit we went from and check out that. Nice. But wait, Detective Cadell, you said they're still there, these unreachable commits, asterisks for now, until something. Until garbage collection, maybe. Not really, maybe. Git has a very sophisticated garbage collection system that does a bunch of efficiency stuff. I won't dive into that. Its main objective is to take the current way we've been storing our objects, which is in that .git objects folder, sort of loose and jangling around, loose, and deleting them, but turning that information into something called a pack file. Now, again, not enough time. Pack files are where Git wins the version control wars, really, really, really. And again, if you want to deep dive into pack files, that very handsome Cave Explorer and his team did that 2 years ago, so check out the links in the link tree later. But the reason we're looking at the garbage collector is because it could possibly clean up those unreachable commits. Possibly. Right, Refy, we've got a problem. We're just jumping around randomly in time, hoping to find the crime. We need to figure out how and when this happened. We need a tool. We need a better way. You weren't expecting that one, were you? There you go.
Man, this search is gonna take a lifetime. It's like looking for a needle in a haystack.
It is, Refy, because we're just guessing where we're going. We need a tool to help us figure out when to go to, and we have such a tool. It is the fantastic Git bisect. Bisect, meaning to cut or divide into two pieces, essentially performs a binary search on your ordered history, looking for whatever it is you're looking for. So for us, we're looking for the moments the unit tests were first brutally murdered and thrown into the streets. Rest in peace. So we'll do that with bisect. We'll start the process by saying git bisect start, and that just warns Git, hey Git, shit's about to get weird. Prepare yourself. Then we give Git two pieces of information. Git bisect good and a reference a moment in time, and git bisect bad and a reference a moment in time. And all this tells Git is good is the last time I know for sure the tests were still working. And bad is the earliest moment I know for sure the tests weren't working. And that just creates a smaller range for this search to happen in. Now Git has this information, it springs into action. It checks out the center commit in that range that you just defined, and then sort of just sits there looking at you funny like, huh? because it needs your help. You need to tell it now if this commit is a good or bad one. So for us, we will run our tests again. And in this case, on D, whilst we're checked out with D, the tests pass. So we say git bisect good, and git carries on. It's able to eliminate this commit and everything to the left of it, everything before it. Now git checks out from the remaining range that it has the middle commit. Again, we run the tests. This time the tests, they failed. It's not able to eliminate this commit, but everything to the right, it knows it was at least this commit. So there, everything to the right is gone. Checks out the remaining commit, and we do the same process, run the tests. This time the tests, they pass, git bisect good, and immediately git stops and goes, hey, F. F was the first bad commit, I found it. We say to git, hey, chill out, bro. Git bisect reset. Take me back to the normal way of git working. And we've got it, Refy. B99 is our naughty commit. The moment the tests were murdered. And look at this. Look at this commit message. Made some good changes. Yeah, klar. The best thing about Git is everything's tracked. So we can tell who did it. We can look at the diffs of the commit and with the git show command like this. And oh, God, I'm sorry to put that on the screen again. You've already seen the brutality. You've seen it once. Just don't look too closely. That's the moment the unit tests were butchered and how they were butchered. But even better, we can look at the commit author and it's mystery user. Great, they've obfuscated their identity.
Curses. I thought we were hot on their tail. It looks like the perp's gonna get away with this.
Well, hang on a second, Refy. There's something we've missed. In the repository at commit F, B99, there's a file here called secret.txt that doesn't exist in the present. The perp has left a clue. Amazing. Cadets, I know it's a very hard day, right? You experienced a very brutal crime, but it's tradition in Detective Academy to take a group photo. We hang it on the wall in the halls of the Detective Academy. Insert the rest of the analogy. I'm tired. So let's take a selfie. If you don't want to be in it, hide your face, and I'm going to get those lines to pretend that I was presenting to everybody. So here we go. Let's clean up this dirty-ass camera. And smile and wave if you want to be in it. Okay, good. All right, come on. There's been a crime, please. Serious faces now, all right? Goodness, can't take you anywhere. Oh, it's a bit early. This is exciting, right? The perp has left evidence. They didn't destroy it. They tried to destroy it, but they didn't succeed. In B99, where we are now, there's this secret.txt file that exists, right? So they tried to delete it. We can cat out the contents of that secret file, and maybe there's a clue. Look, here it is. It's just gobbledygook nonsense again. All right, don't worry. Pass it off to the techies, and we'll continue our investigation, all right?
Hey, partner, out of pure curiosity and educational purposes, if the perp had been smarter, how would they have properly disposed of those secrets?
It's an interesting idea, Refy. And it makes a lot of sense, because sometimes to catch a criminal, you need to think like a criminal, right? So yes, let's think how we would properly have destroyed those secrets if we were the criminal. To begin with, the problem that we've got is that at some point in time, B99, this file was added, these secrets. And at some point after that, the file itself was deleted, and those changes were tracked in Git. So remember, Git can store changes over time, so that blob of the secrets is still in your repository. Not great, right? And that's one thing. But the other side of the coin is, on the perp's machine itself is one thing, but as soon as they push their changes to a cloud, that means other other developers can access that secret blob, and the problem propagates. So what we need to do is go through history, looking for this secret file in every commit. And the moment that we find it, we delete it, and we overwrite the commit itself, getting rid of the old one. Right? Not great, but there is a tool to help us with that exact job, and it's the utterly terrifying git filter branch. Filter branch is a scary-ass command, and even in the man file of filter branch, it goes, "Oh, warning, plethora of mangled histories if you use this command. Everything will be destroyed." Bleh. And in the wrong hands, filter branch is very, very dangerous. However, for us as professional detectives, we're going to learn how to use it. Nice. So I will be upfront. If it's secret removal you want to do, there's easier ways to do it. For example, Git filter-repo is one of those tools. Git itself even recommends this as a secret removal tool. You can install it using your package manager. But for us, filter branch. Filter branch takes as its main argument a rev list, which is just a range of commits, a range of history. So Default is the branch that we're on, hence the name filter branch. Makes sense. It will do some history-altering action that we give it on every single one of those commits in that rev list, deleting, overwriting those blue commits, not affecting other branches in this case, for example. Now, you might be looking at that going, Detective Goodell, I've learned about unreachable commits earlier. Those blue commits, they just disappeared. Where are they? Are they still there? Well then yes, 10 points to Gryffindor if you said that, because for now, those commits are still on your machine, still available. They're sort of unreachable. Let's look at that. If we use the git show ref plumbing command, awesome command, gives a list of all of your commits and the human-readable references they connect to, like the branch name or the version tags, etc. We can see this original subrefs. I didn't create that, Git itself did. So when we ran the filter branch, our original commits were backed up, because although filter branch is a scary-ass command, it's just trying to be a good guy. Very specific analogy there. Rick and Morty, go check it out. Okay, not a lot of Rick and Morty fans there. That's fine. That's fine. What about the garbage collector? Right now, if we were to run the garbage collector, those commits, are protected with that protective layer wrapper of the original refs. And we can even use that protective wrapper, that reference that's been created, to check out those commits that we thought had been gone, and they're back, right? All up until we do something that updates and deletes that protective wrapper around them. Now, if we were to run the garbage collector, those commits would finally be erased from history. Delicious. So the other part of filter branch is the filter. This is weird. There's loads of filters. I'll let you look at all of them yourselves, but we're going to look at two, because one, message filter, is very easy to help us understand, and index filter is the actual useful one. Filters affect basically an area of history, a small slice of history on every commit you run it on. So message filter affects the commit message for every commit you run it on. So takes a standard input, the original commit message, and whatever you print out to it at the end, standard output, is the new commit message. Okay, let's have some examples, because that was really weird and complicated. If we were to use message filter, and the command after it is in the quotes, so echo, we're just printing out glory to Super Earth, right? So all of our commits would turn into glory to Super Earth, the commit messages. I'm not entirely sure why you do that, but possibly because you're a good democratic patriot. This is you. All right, good. Again, weird, but we'll carry on. And a better idea is to manipulate the incoming string. We can use a sed programmer like this to put little hyphens around the original commit message. Again, not sure why you do that, but examples. Or you could take the original commit message and base64 encode it, and it would look something like this. Kind of looks familiar. Anyway, so there's some examples for message filter. Before we run our message filter branch command, we have this list of commits. After we've run it, we still have our original commit in the system, and we have our new commit. What's really important is the author for both commits stays the same. We don't want to change any other bit of history, just that tiny slice, just the message. And even more importantly, both commits point to the exact same tree object, because we don't want to change anything else. Nice. Interesting. Okay. Over to the useful one, index filter. Index filter affects its small area of history is the index of a commit, aka the files that commit knows about in that moment. And we can always query that information with the lsfiles plumbing command. So let's see some examples how this works. If we run filter branch with the index filter, and its command after it is git add and another file on my machine, then it would be as though that file had always been there throughout history. It was always there, you just weren't paying close enough attention. Or you've probably guessed it, the usual important one, which is rm file. Get rid of a file from the index, and that would make it as though the file was never there. You didn't see anything. Hide behind the podium. Haven't got time for this, got to keep moving. So you've probably guessed it, that's how we remove secrets. This is the scary-ass single line, but it's way too long, so broken into multiple lines, command that you can copy and paste and use to delete secrets. We're going to understand each and every bit of it, because it's weird, but it's very easy. It uses two filters. With the filter branch command, you can use one or more filters. It uses index filter and tag name filter, and each filter, after it, has the little command it's running in yellow. We're going to look at both. We've seen index filter already, rm, blah, 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 blah. Ignore unmatched flag is really, really useful, because if you rm a file that doesn't exist, it will crash and complain. But if you add this, it won't. It'll just go, oh, no file, skipping on, carry on. Because maybe that secret file was not always there throughout history. Got to keep that in mind. The other one, tag name filter, very simple. The area of history it changes is the tag name. So like version 1, version 2, version 3. Okay, stalling for time. Basically updating the tag names. And this is important because the commits that tags are pointing to might have changed now. So this cat just basically says, hey, point back to the correct commit now. And it goes, that's version 1 now because that commit might have changed. The filter branch has some options. Prune empty is awesome because if the original commit only added secrets and now that commit's empty, then we can just get rid of that commit. We don't need it. It's empty. Nothing's in there. Force is great because it shows us, again, filter branch is trying to protect us from ourselves, right? Without this flag, if filter branch runs and it sees, yo, you've got original refs backed up. I'm not doing anything. You crazy, man. Force goes, yo, filter branch, I'm crazy. Run, I know what I'm doing. I'm the admin. Let's go, right? Dash dash is a Unixy thing to say that's the end of your options, and dash dash all is the rev list, so the main argument. And all is basically all branches, all tags, right? So change everything. Now, the final problem, so that was the copy and pastable command. The final problem is those other criminals, those other developers that have your secret blobs. And the only answer here is a force push. You should never force push. Sir, should you force push? Never. Good. Apart from this now moment, you need to force push because you've just changed history forever. So you need to force push all, everything. And the only tip I can give you here, try and avoid it, but if you must, do it with your team, in a meeting. Call people in physically into the same meeting room or online. Let them see what happens when you hit enter. Let them understand the chaos you've just inflicted upon them. Good.
Detectives, detectives! It was base 64 encoded.
It's been me. Of course, Reffy, base 64. How did we not figure this out? I knew I recognized that format. Base 64, we can decode. So let's decode our secret that was in the file and let's see if it gives us a clue. It says, it was me. It's a confession, Reffy. We've got the criminal. It was me, your partner. Reffy?
I'm sorry, partner. It was either me or you. I didn't have a choice. He told me he'd revert my child commits if I didn't do what he said.
Reffy, how could you do this to me, buddy? We've known each other for years. You should have spoke to me. I could have helped you. Oh, who even is this guy?
All I know is he goes by KB. He looked just like you, but with a mustache.
Reffy, I'm seeing a tunnel, man. I'm not gonna make it. Help me, Reffy, please.
I gotta go. I'm sorry.
Reffy. What the hell is a Ken Badal? It's a very specific reference to a very stupid YouTube channel. Anyway, thank you all for being here for my dumbass talk. I really appreciate it. Socials on screen. Use Blue Sky, not Twitter. The link tree is there. QR code takes you to the same place, I promise. And the final bit is I'm one of those assholes that has my very own branded shit. So I've got some Ben Cadell stickers. I've got some Ken Badal stickers. I did have a bunch of Reffy stickers, but it's the end of the year, so they're all gone. The other conferences took them all. I'm so sorry. I've got some Ben Cadell pins and some Android with mustache pins known as Kendroids. Anyway, if you want some of that shit, find me. I'm usually here, unfortunately, but there you go. So thank you again, and have a great rest of Droidcon Italy.
I'm so nervous to be here right now. I don't know whether to present you an Oscar or see if anyone's got any questions.
I'll take
Should
an
we go
Oscar,
with the
thank
Oscar?
you, yeah.
Let's do that. Okay. Congratulations for Best Producer, Director, and Actor of the Year. It's Ben Cadell.
I want to thank my parents. Thank you, though.
Nice work, all right?
My ego can only take so much.
No, I don't think there's a limit.
Yeah.
Is anyone brave enough? Has anyone had the chance to think of a question? There wasn't time to breathe, I don't know. Any questions? Anybody? This microphone over here, if you want to.